Welcome to our latest YouTube episode, where we dive into the astonishing new discoveries made by the James Webb Space Telescope as it peered into Uranus. Get ready to embark on a journey through the cosmos and uncover the secrets of one of our solar system's most enigmatic planets. Did you know that Uranus has rings? Yes, that's right, the seventh planet from the Sun. NASA's James Webb Space Telescope, JWST, has recently taken an impressive image of Uranus, revealing its rings in unprecedented detail. In this image, even the elusive Zeta ring, the one closest to the planet, is clearly visible. But JWST's journey didn't end there. It also captured an impressive view of 14 of Uranus's 27 moons. From the well-known Oberon and Titania to the whimsical Puck, these moons are elegantly displayed in their cosmic ballet. Uranus has a rapid 17-hour day, leading to a constantly changing scene of storms and moon movements. To capture this, the JWST used advanced exposure techniques, allowing us to see these dynamic phenomena in stunning clarity. And there's more. The telescope's sensitive lenses also picked up faint background galaxies, appearing as orange blots in the image. Plus, two larger, fuzzier galaxies add to the scene, enhancing the deep space ambiance. Join me in this video to dive deeper into the wonders of our solar system neighbor. Looking back to the 1980s, Voyager 2's visit to Uranus showed us a seemingly calm, solid blue sphere in visible light. Now, with the JWST's infrared capabilities, we're uncovering the hidden layers of this enigmatic planet. Discover a new perspective of Uranus, an active, icy world full of intriguing atmospheric phenomena as seen through the lens of the James Webb Space Telescope, JWST. The centerpiece of our exploration is the seasonal North Polar cloud cap. The latest Webb images offer more intricate details than those captured earlier this year. We observe a striking white inner cap, accompanied by an enigmatic dark lane extending towards the planet's lower latitudes. But there's more than just calm beauty here. Uranus is a hive of activity, with vivid storms arising near and just south of the polar cap's border. Scientists are avidly investigating these storms, their frequency, intensity, and origins. It appears these tempestuous events may be influenced by a combination of seasonal shifts and atmospheric fluctuations. Interestingly, the polar cap becomes more prominent as Uranus tilts its pole towards the Sun, especially as it approaches solstice and basks in more sunlight. The next solstice celebration on Uranus is in 2028, and astronomers are eagerly anticipating potential changes in these atmospheric features. Uranus stands out as a cosmic maverick, spinning on its side at an extreme tilt of 98 degrees. This unusual orientation results in the most dramatic seasonal variations in our solar system. Imagine this: for a quarter of Uranus's year, one pole continuously basks in sunlight, while the other endures a 21-year-long winter. Now, with the advanced capabilities of the Webb telescope, astronomers are gaining unprecedented insights into this fascinating planet. We are now experiencing an unparalleled view of Uranus and its unique characteristics thanks to the James Webb Space Telescope, JWST. The clarity of these images is so remarkable, they almost seem to leap out for a high five. This is more than just a visual feat. It's akin to having a detailed map for future space missions to Uranus. JWST's precision is setting the stage for profound cosmic exploration, with NASA aiming to reach Uranus by the mid-2030s. Stay tuned for future updates in our upcoming videos. To fully appreciate the prowess of JWST, consider its comparison with the Hubble Space Telescope's earlier images. Side by side, these pictures strikingly demonstrate JWST's superior infrared imaging capabilities over Hubble. Moreover, Voyager 2, the enduring space probe, which has been transmitting data for over 45 years since its launch, made significant discoveries during its 1986 flyby of Uranus. it detected 2 new fainter rings, increasing the known total to 11. Interestingly, only Voyager 2 and the Keck Observatory on Earth have been able to clearly observe these 2 elusive rings. While Hubble did detect 2 other faint outer rings 2 decades ago, raising the ring count to 13, it missed the ones Voyager 2 identified. This highlights a key difference in their observational capabilities. Hubble operates in ultraviolet, visible, and a small portion of the infrared spectrum, whereas JWST covers the full infrared spectrum. What truly sets JWST apart is its significantly larger mirror. This allows for superior resolution and clarity in infrared imaging compared to Hubble, showcasing its distinct advantage in observing the wonders of the universe. JWST's latest images bring a striking view of Uranus, especially its North Pole, into sharp focus. Due to Uranus's unique tilt, as viewed from Earth or from JWST's position at the L2 Lagrange point, we see its North Pole head-on. In these images, the pole is adorned with an ice cap, usually visible only in summer when bathed in direct sunlight. Hey there! If you're enjoying the video, please take a moment to like or dislike it, so we can tailor our content to your preferences. Also, don't forget to subscribe to our channel and hit the notification bell to stay updated with our daily videos. The image also captures some of Uranus's 27 moons. Intriguingly, several are visible within its rings, showcasing JWST's remarkable capabilities. We'll take a step back now to gain a broader perspective. Later in this video, we will delve into how Uranus's moons play a crucial role in both diminishing and sustaining the planet's rings. This fascinating interaction is not unique to Uranus. Similar dynamics are observed around Saturn and Jupiter, as noted by astronomers. Uranus's moons, often referred to as "they literary moons," owe their names to characters from the works of William Shakespeare and Alexander Pope. Among these, Miranda, Ariel, Umbriel, Titania, and Oberon stand out. Miranda, named after the character from Shakespeare's The Tempests, presents a strikingly unusual landscape despite its modest size, just 1/7 that of Earth's moon. Spanning 500 km in diameter, Miranda exhibits a landscape teeming with distinct features. Its 3 Coronae lightly cratered regions, characterized by ridges and valleys, are a stark contrast to the heavily cratered surroundings, akin to contrasting patches on an old coat. The moon's immense fault canyons, some plunging 12 times deeper than the Grand Canyon, further add to its mysterious charm. The low gravity of Miranda means that a rock dropped from the top of its tallest cliff would take a leisurely 10 minutes to reach the ground. Scientists are intrigued by the processes that have shaped Miranda's unique features. One compelling theory suggests a massive collision that led to its chaotic reassembly, painting a picture of a celestial puzzle that continues to intrigue and fascinate researchers. Ariel, one of Uranus's moons, presents its own cosmic enigma. Smaller than Earth's moon, with a diameter of approximately 1,160 kilometers, Ariel captivates with its distinct terrain. This moon exhibits a mix of cratered regions and smoother plains, hinting at a complex geological past. Unlike the dramatic features of some other moons, Ariel's landscape is more subtle, its surface lacking the pronounced contrasts seen on moons like Miranda. The processes that have shaped Ariel's surface are still under scientific scrutiny, with theories ranging from impact events to internal geological activities. The relatively smooth plains on Ariel suggest past resurfacing events that have erased much of its rugged history, making Ariel a moon of subtle yet intriguing mysteries within Uranus's diverse moon system. Umbriel stands out as the darkest of Uranus's major moons, reflecting only 16% of the sunlight that hits it, similar to the highlands on Earth's moon. This lunar mystery, about 1,200 kilometers in diameter, is characterized by an ancient, heavily cratered surface. The process that has darkened Umbriel's surface over time remains an intriguing puzzle. Its somber appearance adds to the diversity and complexity of Uranus's satellite system, inviting further exploration and study. Titania, the largest moon of Uranus, revealed signs of geological activity nearly 2 centuries after its discovery. Voyager 2's images disclosed a remarkable system of fault valleys on Titania, extending almost 1,609 kilometers, 1,000 miles, along the moon's terminator. The presence of these troughs, fracturing the crust in various directions, indicates tectonic activity on the moon's surface. Furthermore, the valley walls facing the sun are coated with highly reflective material, possibly frost, adding to the moon's geological intrigue. Oberon, the second largest moon of Uranus, discovered in 1787, bears a resemblance to Umbriel with its heavily cratered surface. However, Oberon is distinct from its sibling moons Ariel, Titania, and Miranda due to its abundant craters. Its composition, a mix of ice and rock, aligns with that of Uranus's other large moons. A notable feature on Oberon is a prominent mountain, soaring about 6 kilometers above the lunar surface, adding a dramatic touch to its rugged terrain. The rings of Uranus are distinct in their composition and structure. Most are only a few kilometers wide and are characterized by a lack of dust. Instead, they primarily consist of large bodies, ranging from 20 centimeters to 20 meters in diameter. This unique composition distinguishes Uranus's rings in our solar system. The rings of Uranus present a curious mix of characteristics. While some rings are optically thin, composed mainly of small dust particles, others, like the Lambda ring, are both narrow and faint, yet host larger bodies. The scarcity of dust in these rings might be influenced by aerodynamic drag from Uranus's expansive exosphere. Current theories suggest that Uranus's rings are relatively young, likely not more than 600 million years old. Their formation is believed to be the result of the collisional breakup of moons that once circled Uranus. These catastrophic events would have transformed the moons into a myriad of particles, now persisting as narrow and optically dense rings in zones of maximum stability. The interplay between Uranus's inner moons and its rings is a complex and dynamic one. These celestial bodies constantly interact, influencing and disrupting each other's orbits, creating a system marked by chaos and instability. Computer simulations indicate that such interactions may lead to eventual moon collisions. For instance, in the coming million years, there's a predicted collision between the moons Desdemona and Cressida, and within 10 million years, Cupid might collide with Belinda. Further potential collisions involving Perdita and Juliet also loom on the horizon. This ongoing celestial drama ensures that the rings and inner moons of Uranus are in a state of continual flux, with moons colliding and merging over relatively brief astronomical timescales. The moons within Uranus's rings serve a dual purpose in shaping this unique system. Firstly, they contribute to the creation of debris through ongoing collisions, adding to the ring material over time. Concurrently, Uranus's rings are predominantly made up of larger bodies, ranging from 20 km to 20 m in diameter, and are notably deficient in fine dust particles. This scarcity of dust is a significant factor in the ring's apparent thinness when observed from our perspective. However, this phenomenon may be part of a larger cosmic story. A recent study of data from the Cassini mission to Saturn revealed a similar process of ring loss occurring there. Over a 13-year period, scientists observed the accumulation of cosmic dust on Saturn's icy rings. Contrary to expectations, the rings showed limited dust accumulation, suggesting a narrow window for this process. Meteoroids entering Saturn's ring system were seen to expedite material loss, pushing it towards Saturn at a significant rate. This finding implies that, astronomically speaking, Saturn's rings might only last for a few 100 million years. Applying this insight to Uranus, some scientists speculate that its rings could have once been much larger, similar to Saturn's present-day rings. Over time, they might have diminished due to processes like those observed at Saturn. Interestingly, the moons of Uranus might also play a role in replenishing the ring material. Through processes like cryovolcanism, these moons could be injecting fresh material into the rings, potentially slowing down their rate of disappearance. This ongoing interaction between the moons and the rings adds a complex layer to our understanding of Uranus's dynamic ring system. When Enceladus, one of Saturn's moons, serves as a prime example of a cryovolcanic moon. Cryovolcanism refers to the eruption of volatile substances like water, ammonia, or methane instead of traditional molten rock. This fascinating process is vividly demonstrated on Enceladus, particularly through its distinctive tiger-striped fractures located near its south pole. These fractures are the origin of powerful geysers and plumes, ejecting water vapor and icy particles into space. However, Enceladus is not the only moon displaying cryovolcanic activity. Other icy moons across our solar system also show signs of this phenomenon. Ariel, a moon of Uranus, for instance, is believed to have the youngest surface among all Uranian moons, indicative of relatively recent geological activity. While it's uncertain whether Ariel is currently geologically active, its surface has undergone complete resurfacing since the solar system's formation. Similar features have been observed on Charon, Pluto's largest moon. The James Webb Space Telescope, JWST, humanity's most powerful space telescope. Launched to succeed the Hubble, JWST's advanced technology allows us to see the universe like never before. We'll discuss its unique capabilities, including its infrared vision, which is key to unveiling hidden aspects of planets like Uranus. The JWST's recent focus on Uranus has revealed stunning details about the planet's atmosphere, rings, and moons. In this part, we'll delve into these findings, exploring how they enhance our understanding of Uranus's composition, weather patterns, and the peculiarities that make it stand out in our solar system. Uranus's atmosphere has always intrigued astronomers. Thanks to JWST, we now have a clearer picture of its chemical makeup and the dynamic processes occurring within. This segment will discuss the surprising elements discovered and what they tell us about the planet's climatic and environmental conditions. Not just the planet itself, but Uranus's rings and moons have also come into sharper focus. The JWST has provided unprecedented views, revealing new details about their composition and potentially uncovering unknown moons. Here, we'll explore these fascinating aspects and their significance in the broader context of solar system science. Finally, we'll look ahead at what these discoveries mean for future missions and research. How will the JWST's findings influence our next steps in exploring Uranus and similar distant worlds? This segment will consider the potential for new missions and the ongoing impact of these groundbreaking observations. Explore one of Uranus's most intriguing features, its tilted axis. Unlike any other planet in our solar system, Uranus rotates on its side. We'll delve into how the James Webb Space Telescope's observations are helping scientists understand the impact of this unique orientation on the planet's weather patterns and magnetic field. Despite being an ice giant, Uranus exhibits some unexpected thermal properties. In this part, we'll examine JWST's findings on Uranus's heat distribution. These observations challenge previous theories about the planet's internal heat source and offer new insights into its core structure and energy balance. Uranus's ring system, often overshadowed by Saturn's, is a wonder in its own right. Here, we'll discuss how the JWST has provided clearer images and data about these faint rings, revealing details about their composition, origin, and the dynamic processes that govern their shape and behavior. One of the most visually striking features of Uranus is its color. This segment will focus on what JWST's findings tell us about the reasons behind its unique blue-green hue. We'll explore the atmospheric composition and the role of methane and other gases in creating this distinctive coloration. Uranus's magnetic field is unlike any other in our solar system. In this part, we'll delve into the recent data from the JWST that sheds light on the peculiar orientation and structure of its magnetic field. We'll discuss the implications of these findings for our understanding of planetary magnetism and how it affects space weather. Solar winds play a significant role in shaping the environments of planets. This segment will explore how Uranus, with its unique axis tilt and magnetic field, interacts with solar winds. JWST's observations provide critical data on this interaction, offering insights into the planet's upper atmosphere and auroras. Uranus and Neptune are often compared due to their similarities. In this segment, we'll take a closer look at how the recent observations of Uranus by JWST help differentiate these two ice giants and what they reveal about the diversity and evolution of planets in our solar system. As we discover more exoplanets, understanding our own solar system's planets becomes increasingly important. This part will discuss how studying Uranus with JWST can inform our understanding of distant ice giant-like exoplanets, especially in terms of atmospheric composition and thermal properties. This segment will highlight how the technological advancements embodied in the JWST have revolutionized our approach to observing distant planets. We'll look at the innovations that have made these detailed studies of Uranus possible and the potential for future technological developments. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q and sessions with experts. Your membership will grant you the chance to participate in Live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.